Good day, students. Welcome to mathgotserved.com. In this clip, we're going to be going over the factor and remainder theorems. Before we get started with the problem solving process, we are going to take a look at what the factor and remainder theorems are. Let us start with the remainder theorem. The remainder theorem. Now, what does the remainder theorem say? Well, this is what it says. If a polynomial, let's say the polynomial is f of x, if that polynomial f of x is divided by a binomial x minus r, then the remainder is, let's call the remainder uppercase r, okay? The remainder is f of r. Okay, so what is this theorem telling us? If we're dividing a polynomial by a binomial of this form, where a is equal to 1, we can simply find the remainder by finding the 0 of that divisor and then substituting it into all the x's in your dividend polynomial function. Okay, so in essence, you do not really have to divide out the polynomial either by synthetic or long division in order to determine what the remainder is. Okay, so that's basically the remainder theorem. Now, the remainder theorem has a special case. The special case of the remainder theorem is the factor theorem. Now, what happens when your remainder is 0? That gives us the factor theorem. So the factor theorem is as follows. A polynomial, let's say f of x, has a factor of the form x minus r if and only if the function evaluated at the 0 of that factor, f of r, is equal to 0. Okay, what this is saying in essence is that the remainder f of r, as we indicated above, is equal to 0. This is what a factor is. If a number is a factor of another number, when you divide that number by that factor, you do not have any remainders. Okay, now let's take a look at an example. Okay, example number 1. We are to find the remainder if the polynomial function x to the third minus 7x squared plus 20x minus 22 is divided by x minus 4. Okay, so find the remainder if this polynomial function, this dividend, is divided by this divisor in 3 different ways. Okay, in this lesson we're going to be reviewing 2 other ways to find the remainder, namely the synthetic division process and the long division process. Okay, so 3 different ways. That's the first part, and then you have to answer the question, is this divisor right here, x minus 4, is x minus 4 a factor of the dividend? is it? Okay? Alright, let's start with part 1, which is to find the remainder. Okay? So find the remainder. Method 1 that we're going to use is the the remainder theorem. Okay, the method 1 is the remainder theorem. So in order to use the remainder theorem, first of all, we have to identify what the divisor is. Okay, so we take the divisor, which is x minus 4. We set it equal to 0, and we will find the 0 of this divisor. Okay, so that can be accomplished by simply adding 4 to both sides of the equation. So x equals 4 is the root of this equation. Okay, now what are we going to do next? We're simply going to evaluate this divisor polynomial, this dividend polynomial, sorry, by the root of the divisor, which is 4. Okay, so f of x is x to the third minus 7x squared plus 20x minus 22. So if you remember the remainder theorem, we'll just simply evaluate this function at the 0 of the divisor. So we're going to go f of, take out the x, replace with 4. F of 4 is equal to parentheses 4 raised to the third power minus 7 times 4 raised to the second power plus 20 times 4 minus 22. Okay? So what we'll do now is simply plug this entire expression into our calculators. If you do so, you end up with the value of 10. Okay? Value of 10. Let me just show you with the calculator real quick. So what we're looking at here is 4 to the third power minus 7 times 4 raised to the second power plus 20 times 4 minus 22. And we get 10. Okay? So what did we just find? We have just found the remainder. Alright? So the remainder is equal to 10 when you divide this function right here by x minus 4. So you see how fast it was to compute the remainder using the remainder theorem, especially if you have a calculator in your possession. Now let's take a look at method 2. We're to use 3 methods. Method 2 is synthetic division. Okay, so let's do that. Method 2 is synthetic division. Okay, so for synthetic division, we have to just set up the polynomial correctly first, and then we can go on from there. Now let's set up our synthetic division bars. We're going to place the coefficients of the function of the coefficients of the dividend function in the division bars in such a way that no missing degree term are included. Okay, so we don't want to have any missing degree terms. So we have 3, 2, 1, 0. In this case, no degree term is missing, so that's perfect. Had it been we had a missing term, we will have to use a placeholder. That's not applicable here. Okay, so there's a 1 in front of the function, so we have 1, negative 7, 20, negative 22. And then we are going to place the 0 of the divisor polynomial, which is 4, right there. And then we're going to carry out our synthetic division. Now, if you recall from previous lessons, you divide synthetically by adding downwards and multiplying across. There is no number here, So we'll start with 0. Okay, so we add down. 1 plus 0 is 1. And then we're going to multiply across. 4 times 1 is 4. Add down again. You get negative 3. Multiply 4 by negative 3. You get negative 12. Add down, you get 8. Multiply 4 times 8. You get 32. Add down, and you end up with positive 10. Now this last digit underneath your division bars is your remainder. And as you can see, our remainder here is equal to 10. And that agrees with our result in method number 1. Now the last method we're going to use to find the remainder is the long division method. Okay, so let's go ahead and do that. Method 3, long division. Okay, long division, this is the longest method. Think about the name. So let's go ahead and set it up. We have our long division bars. We will extract the dividend function exactly as it is, x to the third minus 7x squared plus 20x minus 22. Now, you also want to follow the same guidelines as the synthetic division process. If any degree terms are missing, you have to put a placeholder there, okay? So we have 3210 as indicated earlier. There are no missing degree terms when you're descending from the highest degree to the constant. So this is fine. Now we're dividing by x minus 4. So let's place x minus 4 out here. Okay, so how do we do long division? What we'll do is we just focus on the leading term of the divisor and the leading term of whatever sections of the dividend polynomial we are factoring, okay? So we are now looking at the leading term of this original dividend polynomial and the leading term of our divisor, okay? And you ask yourself, how many times does x go into x to the third? X goes into x to the third x squared times, because x squared times x is x to the third. Okay, so we'll multiply that out. If we multiply, we have x to the third. X squared times negative 4 is negative 4x squared. Okay, now what we'll do is we'll proceed to subtract. Remember, division is just repeated subtraction. You're repeatedly extracting a factor from the dividend, and the number of times you can do that is basically your quotient. Okay, so let's extract this factor, put a minus. When you carry out your subtraction, the first terms always cancel out. That's by design. Okay, so x to the third minus x to the third, that goes to 0. Negative 7x squared minus minus is a plus. So negative 7x squared plus 4x squared is negative 3x squared. And you see this negative 3 right here? That's the same as this negative 3 in the synthetic division algorithm. Okay? Now, what we're going to do next is bring down another term. Since our divisor is a binomial, we're going to be bringing them down one at a time. So we'll have 2 terms at every time. If we eliminate this, for example, we'll bring down 2, okay? So we have plus 20x. What we're going to do now is repeat the same procedure. How many times does x go into the leading term here? How many times does x go into negative 3x squared? Or x times what gives you negative 3x squared? The answer is negative 3x. Okay? Negative 3x times x gives you negative 3x squared. Let me change the color there. Gives us negative 3x squared. And then negative 3 times 4 gives us positive 12x. And now we're going to subtract this factor again. When we carry out our subtraction, what do we get? If we carry out the subtraction, we have these two cancel out, they add up to 0. 20, positive 20 minus plus 12, minus times plus is minus. So we have 20 minus 12, which is 8x. And then we'll bring down the last term since we're dealing with 2 at a time, okay? So we'll bring down negative 22. Okay, now we're going to carry out this procedure one last time. How many times does x go into 8x? It goes into 8x positive 8 times, okay? So we're now down to the 8 right here in our synthetic division. That's basically where we're at. Okay, and now multiply. 8 times x is 8x. 8 times negative 4 is negative 32. And we subtract that factor again. Remember, division is repeated subtraction or extraction of factors. So if we carry out the difference, that will give us the remainder that we are looking for. So 8 minus 8, 8x minus 8x is 0. Negative 22 minus minus 32, minus times minus is a plus. So we have negative 22 plus 32. That gives us 10. And that, ladies and gentlemen, is our remainder. Okay? So if you take a look at these three methods that we used just now, which is the most efficient method for finding the remainder? If you have a calculator and you're good with your order of operations, the remainder theorem is normally the fastest. Okay? And the synthetic division is not too far behind. Sometimes this might actually be better. So what's the significance? What's the relevance of methods 2 and 3? Well, methods 2 and 3 do not just tell you the remainder. They also tell you the quotient. Okay? Synthetic division tells you the quotient. If you take a look at these, are the coefficients of the depressed polynomial or the quotient, which is, let's write it down. Let's see, 1x squared is a degree less than the original. 1x squared minus 3x plus 8. And then we have the remainder, 10 over x minus 4. Okay, so these two tell you not just the remainder, but they also tell you the quotient. Now, if you take a look at these two methods, synthetic and long division, which one is the better method for dividing polynomials? Well, it depends. Synthetic division is known for its speed. It's very, very fast. And long division is powerful. Okay? Now, why do we ascribe these qualities to these two methods? Well, synthetic division, if you are presented with a problem of a certain setting, let's say the divisor is of the form x minus r, then it's really easy to use synthetic division to divide and get your answer. But if you have a divisor that's of the form, let's say, ax squared plus bx plus c, or if you have ax minus r. If the divisor is not of this form, then this method could fall apart, or it could be very, very difficult to use, okay? So when it's presented in this form, you definitely want to use synthetic division, but in other forms, you end up having to rely on the long division. So that's why this method is powerful, because it can handle any kind of division of polynomials problem you throw its way. But this one is limited. When you present problems that are of a particular setting that it can handle, it's extremely fast to use. Okay? So it's important that you know all three methods, and you also want to know the best methods to use for any particular problem. Thanks so much for taking the time to watch this presentation. I really appreciate it. If you found the contents of this tutorial helpful in your study of the factor theorem and the remainder theorem, do give us a thumbs up. Your positive feedback is very valuable to us. If you have any questions or comments about this presentation, just place it in the comment section below, and we'll be more than glad to support you. Do not forget to subscribe to our channel for updates to other math tutorials such as this. More clips can be found on mathgotserved.com under precalculus. Thanks again for watching and have a wonderful day. Goodbye.